Okay, so I thought what we could do in this video is quickly recap the specific immune response, because that's always helpful to do, and then continue to learn more about the differences between what we call the primary immune response, which is when we first encounter the antigen, and the secondary immune response, which is the second time we're infected or we encounter that same foreign antigen. So let's have a look first of all at our recap. So we're going to recap what we call the specific immune response. Remember, it's called the specific immune response because the T lymphocytes and the B lymphocytes that we need are the correct lymphocytes with the correct complementary receptors for this specific foreign antigen. So let's start with the T lymphocyte response. Now we call this the cellular response because T lymphocytes respond to cells, your body cells basically, that are presenting foreign antigens. So this might be one of your phagocytes that's engulfed and destroyed a pathogen and is presenting those foreign antigens. It might be one of your body cells that's infected and is presenting the foreign antigens. It might be a cancerous cell that has foreign antigens, or it might be cells from a transplanted organ or transplanted tissue that have foreign antigens. But yeah, they're responding to your cells that are acting as antigen-presenting cells. So here is a T lymphocyte. It's specific, so we need to activate the T lymphocyte that has receptors that are complementary to this specific foreign antigen. And you can see here that the complementary receptors on the cell surface membrane of this T lymphocyte are binding to the foreign antigens that are being presented. So this, for example, could be a phagocyte, like a macrophage, that is presenting those foreign antigens on its surface. And as the receptors of the T lymphocyte bind to those foreign antigens, that T lymphocyte is going to be stimulated or activated. We can call this clonal selection. So that T cell with the correct complementary receptors has been selected for, and it's going to undergo cloning by mitosis. So it's going to clone by mitosis, which we can call clonal expansion. But you can also just say it clones itself by mitosis, and then it's going to differentiate or specialize into three key types of T lymphocyte. So we've got the T memory cells. Now the T memory cells can basically recognize the same foreign antigen. So if you are infected with that same pathogen and they encounter that same foreign antigen again, they can quickly clone and differentiate to produce more killer T cells and more helper T cells. The second type of cell that the T lymphocyte can differentiate into is the killer T cells. Now these produce chemicals, for example, perforins. And perforins we know can make holes in the cell membranes of cells that are infected with, say, a virus, and destroy those cells. So they can actually make holes so those cells become fully permeable, and it will lead to the destruction or death of those infected cells. We've also got our helper T cells. Now these ones are really important, we know, because they activate the B cells or the B lymphocytes. They also produce chemical signals called cytokines. Now these chemical signals are going to cause more T killer cells to be produced by cell division. They're going to cause phagocytes to migrate to the site of infection, and they're also going to help to activate the B lymphocytes. Okay, but what's really important that we say for AQA is that the T helper cells are going to activate the B cells, and that takes us on to our humoral response over here. Now, it's called a humoral response because B lymphocytes, called plasma cells, make antibodies. Antibodies travel in our blood, which is a bodily fluid, also known as humor. It's quite an old-fashioned word for a bodily fluid. But the T helper cell is going to help to activate the B cell. And again, this is part of the specific immune response. So we're not just going to activate any old B cell. It is going to be the B cell that has receptors, or you can call them antibodies, But here they're acting as receptors because they're on the cell surface membrane of the B lymphocyte. But they are the same shape as the antibody that will be produced ultimately. But yeah, the T helper cell is going to activate the correct B cell, so the B lymphocyte that has the complementary receptors or antibodies on its cell surface for this specific antigen. So once the T helper cell has activated the B cell, we again can say we've undergone clonal selection. So that specific B lymphocyte has been selected for. It's then going to undergo clonal expansion. So it basically clones by mitosis to produce lots of the same type of B lymphocytes. Those B lymphocytes are going to clone and they're going to differentiate into two key types of B lymphocytes. We've got the plasma cells that produce antibodies, and we've got the memory B cells, which again can recognize that foreign antigen. So if you are infected with the same pathogen, with the same foreign antigen on its surface, those memory cells will remain in circulation, be able to recognize that foreign antigen and quickly clone and differentiate to produce more plasma cells, which will produce more antibodies. And remember, the antibodies that this plasma cell can make are going to be the same as the receptors or antibodies on the surface of this original B lymphocyte, so they will be complementary to that antigen. Okay, that was my super quick recap. I hope you've watched some of my previous videos as well, because we've done quite a lot on this now. But the reason I started with this is because to understand the difference between the primary and the secondary immune response, you need to understand what happens during the immune response. So let's go ahead now and look at the difference. Now, the primary immune response occurs on the first exposure to the antigen. So that would be described as the primary immune response. The secondary immune response occurs on the second exposure to that antigen. So for example, your primary immune response might just be the first time you're infected with that virus. The second response might occur the second time you're infected with that virus. Or the primary immune response might occur when you have a vaccination, and then the secondary immune response might occur when you actually get infected a few years after you've had that vaccination. So let's start by describing what the graph shows with regards to the differences between the two responses. So we can see on the y-axis, we've got the concentration of the correct or specific antibody in the blood. After the primary response, there is a delay or a lag time before antibody production, which we'll explain in a second. So you can see here, there is a delay of about 6 days before the correct antibody starts to be produced. There's also a slower or more gradual increase in antibody concentration. And we can also see that the maximum concentration of antibodies is lower compared to, if we have a look at the secondary response over here, the maximum or the peak concentration of antibodies is much higher, okay? Now, we could say the converse for every single thing in terms of the secondary immune response. So, for example, with the secondary immune response, in fact, I'll write it down. There's no delay before antibody production. If you look here, the line starts to increase, or the concentration of antibodies starts to increase immediately after the second exposure to that antigen. So there's no delay in antibody production. It's a faster increase in antibody concentration. We can see the gradient of this line is much steeper than this line here. And the maximum concentration of antibodies is higher. So the peak is higher. We're making more antibodies, we're making them faster, and we're making them without delay. So can we explain these differences? Well, the primary response, the first time we are exposed to that foreign antigen, it takes time. Can't just leave it there, can we? But it basically takes time to produce the correct antibody because everything we said on the previous slide has to happen. So it takes time for, you could say, antigen presentation. So we need to have phagocytosis. The phagocytes need to present the foreign antigens. That takes time. It then takes time for clonal selection and clonal expansion. Or you could just say, if you're not using those terms, it takes time for example, B cells to clone by mitosis. And it then takes time for the B or the plasma cells, I'll say. Oh, no, I won't. It takes time for B cells to differentiate into plasma cells. So it's like the whole story has to start from scratch, right? The phagocytes need to present the antigens, the correct T lymphocyte needs to undergo clonal selection and clonal expansion, the T helper cells need to activate the B lymphocytes, the B lymphocytes need to undergo clonal expansion or clone by mitosis, and then the plasma cells need to form the antibodies. So the whole thing takes time. And it's also important to say with the primary response, there are no memory cells activated. So you are starting from scratch. Whereas with the secondary immune response, no clonal selection needed. So no clonal selection or clonal expansion needed. So you're not waiting for that to happen. So you don't have that delay before antibodies will be produced. You've got memory cells present. So memory cells have remained in circulation following on from that primary response that will have produced memory cells. Those memory cells will now remain in circulation and obviously can recognize this foreign antigen because it's the same foreign antigen as on first exposure. Memory cells, for example, memory B cells, which is important to talk about here because we are looking at antibody concentration. Memory B cells quickly differentiate into plasma cells. And obviously, plasma cells are the ones that produce antibodies. So this explains why you're not going to have that delay because you're not waiting for clonal selection and clonal expansion. You already have memory cells that have remained in circulation that can recognize the antigen. And it explains why the gradient of the line is much steeper and why antibodies are produced much more quickly because the memory B cells can quickly differentiate into plasma cells. The plasma cells will produce antibodies and there'll be loads of them. So you're going to have loads of antibodies produced much more quickly and without delay. I hope that's explained it. Let's have a look at a couple of questions. So for example, this one, exam style question number 1, explain why the response to the subsequent infection is much bigger than the response to the vaccination. So the vaccination is here on day 0. And then you can see there must have been a subsequent infection, probably around, well, where's it started to increase, guys? Started to increase maybe round about here, hasn't it? Day 18, round about there, subsequent infection. But we have to explain why the response is much bigger than the response from vaccination. We've got antibody concentration again on our y-axis. So just as a little intro to this, you can see following vaccination, there is a delay, there is a lag where there's no increase in antibody production. Antibody concentration is increasing quite slowly. You've got a very shallow gradient and the antibody concentration does not get that high. Obviously here there's a subsequent infection with the same antigen. You can see there's no delay before the concentration of antibodies starts to increase. You can see it increases much more rapidly. You've got a much steeper gradient and you can see that overall the concentration of antibodies gets much, much higher than following vaccination. So let's explain. So let's start by talking about vaccination. So following vaccination, we could say things like response is slower because it takes time for, we could say, clonal selection. We could say clonal expansion. or we could say mitosis, because remember we need the correct B lymphocyte to be stimulated, and then we need that B lymphocyte to undergo clonal expansion or clone itself by mitosis. So it takes time for all of these things, clonal selection or clonal expansion or mitosis, or you could even say it takes time for differentiation, for that B lymphocyte to actually differentiate into plasma cells. Whereas after the subsequent infection, which I'm assuming is around day 18 from looking at the graph, the response is faster because you could say no clonal selection. So you've already got the memory cells which can recognize this foreign antigen. So you don't need to select the correct B lymphocyte or activate the correct B lymphocyte. You could say, I mean, we still need mitosis and differentiation, don't we? Because we still need the memory cells to differentiate into plasma cells. But you could say, you know, we have memory B cells which can quickly clone by mitosis or quickly differentiate into plasma cells. Okay, so in terms of marking point, you can get 1 mark for this idea. So the idea that with vaccination, there's a slower response because it takes time for clonal selection, clonal expansion, mitosis, differentiation of the correct B lymphocyte. You can get a mark for saying after infection, response is faster because no clonal selection. You can also get a mark for saying memory B cells are present, so they can quickly clone by mitosis or differentiate. And you can also get a mark for saying into plasma cells. Okay, so 4 marking points available, but you would need 3 of them to get all the marks for this question. Let's have a look at 2 more. We've got a little sketch graph going on here. So on day 30, this individual was infected again with the same pathogen as in the initial infection. Sketch a line on the graph to show the antibody concentration from day 30 onwards. So they were infected on day 30, and we know that because this is going to be the secondary response, we know there's going to be no real delay or lag time. So really the concentration of antibodies should start to increase pretty immediately. So I'm going to show it increasing from day 30, I think. But to get the mark, as long as you had it increasing pretty much immediately, so maybe between day 30 to 33, yeah, don't give too much of a delay because there won't be a delay because we've got those memory B cells. But as long as your line starts to increase pretty soon, so from day 30 to 33, they will let you have that mark. I'm going to show mine kind of going up immediately. I'm also going to show a much steeper gradient and a much higher peak, okay? So my 2 marks are coming from making sure the peak is higher and there's a steeper rise. That will get me 1 mark. And making sure there's very little delay, so the line kind of departs the x-axis from between day 30 to 33, very little lag time. That will get me marking point 2. So check I've got all 3 of those things. It's leaving the x-axis pretty much immediately at day 30. I've got a steeper incline and I've got a higher maximum peak, and it is staying higher as well. It will stay higher for longer before it starts to come back down. Explain how memory cells cause the differences between the 2 lines on the graph. So in the initial infection, or we could say the primary immune response, we can say memory cells are not acting, or we can say it's a primary immune response. Okay. So remember, it takes time. We've got to activate the correct B lymphocyte. It's got to undergo clonal selection, clonal expansion, differentiate into the plasma cells to make the antibodies. There is going to be a delay. There's no memory cells acting in the primary immune response. Yes, we do make them following that immune response, but there's no memory cells being activated in that primary immune response. So that could get us 1 mark. You could also get a mark for saying memory cells remained in the blood following the initial infection or the primary immune response. And you could also get a mark for talking about when infected again. So was it day 30 that we were told? So when infected again, round about day 30, no wait for clonal selection or faster cloning by mitosis or memory B cells cloned by mitosis. Or what I always say is memory B cells can quickly differentiate into plasma cells, and that will get you a mark. So it's kind of like, if you think of it as a story, it's like you don't have to start from the beginning of the story. You don't have to wait for antigen presentation, activation of T cells, helper T cells to activate B cells to undergo clonal expansion. You've already got memory cells. And memory B cells can quickly differentiate into plasma cells, which are obviously then going to produce antibodies. So we're not going to see the delay. We're going to see a much more rapid increase in the concentration of antibodies. And because we're going to have more plasma cells making antibodies, we're going to see a much higher concentration. Guys, I hope you found this useful. As always, we're trying to sync up YouTube with TikTok. So check out some of my videos on TikTok this week if you want to see some exam style questions on this particular topic.